Today I will speak to you about environmental free-living amoebas. I teach parasitology in the University of Tor Vergata here in Rome, and this issue is not related to really parasites, because this group of parasites, of protozoans, can be considered opportunistic protozoans. Inside this general group, we can find different genera. Some of them are well known, like Acanthamoeba or Negleria. Some other are less known, like Balamuzia, Sappinia, and Artmanella. We are speaking about free living that can give health problems, meeting the humans and also other animals. I would like to start with the genus Acanthamoeba, and as you can see, it's possible to find Acanthamoeba in two different developmental stages, the cyst and the trophozoites. The host and the localization are quite typical for this genus, because they can create a couple of important pathologies. The first one is rarely some encephalitis, defined as granulomatous amoebic GAE, and especially some keratitis. Keratitis due to the use of contact lenses. And for this reason, I used to say, and it's common to say, that it's probably the most recent parasitic disease in the world, considering the humans, because it was born with the use of contact lenses. When we speak about Acanthamoeba, actually the former taxonomy is now a molecular taxonomy based on the different genotypes. Actually, we have, as you can see on the left part of the slide, we have 17 genotypes, and some of them have already been recognized as pathogens or creating damage in humans. Some like keratitis, some like encephalitis. And considering the scientific literature, we have to take in account that one of these genotypes, the T4, is probably the most spread all over the world. We don't know if it's because it's very common or because it's really more pathogenic than other genotypes. And when we speak about free-living amoebas, we have to take in account some risk factors, and mainly are the contact with waters, free water, so swimming pool, thermal, baths, spas, but also contact with ground. And I would like to remember you that the principal factor risk is represented by the use of contact lenses. And sometimes, for example, we found some cysts of Acanthamoeba even in the liquid of preservation of the lenses. And for the clinical diagnosis, we use, instead to have the scraping of corneal, we ask to the patient to give us the liquid of the lenses or the lenses. And it's possible to perform there a good diagnosis, clinical diagnosis. But we spoke about Acanthamoeba, but there are some other genera. The genus Balamuzia is quite known to give granulomatous amoebic encephalitis. We have another couple of genera, the genus Sappinia, the genus Artmanella, that are quite known to give amoebic encephalitis. And considering Artmanella, I would like to spend some words about the new proposal of systematic on the morphological basis has been proposed to shift the species Vermiformes in the genus Vermameba. Vermameba, because it's quite typical, the stick shape of the trophozoite, as you can see on the upper left side. And considering the genus Vermameba or Artmanella vermiformis, there are some records considering the role in human keratitis. And the last genus of the group is the killer genus, because it's the genus Negleria, is the killer genus because can provoke the primary amoebic meningoencephalitis, and the most part of the diagnosis has been based on autoptic diagnosis because it's usually fatal, and this is the reason because in our opinion and the general opinion, probably the illness provoked by Naegleria are completely underestimated. And speaking about free-living amoeba, we have naturally to consider the pathogenic role, direct role, but it's very important also to consider that they are the good Trojan horses, in the sense that inside the cyst of acanthamoeba we can find a lot of bacteria, and here you can see a list of already known and described bacteria endosymbiotic inside the cyst of acanthamoeba, but also some viruses are found inside. And between these records, it's very common, for example, and very well known, the occurrence of the association between acanthamoeba and Legionella, for example. But as you can see, there are a lot of, so we have to consider the importance also in the environmental monitoring, not only for the direct diagnosis of amoebae, but also for this role that they can play in carrying pathogens. And considering the environmental situation in Italy, there are few records in the past, and are records considering the morphological diagnosis. So for this reason, we start having an idea of what happened in Italy, and we started with two principal aims in our study. The first one was really identify the amoeba, environmental amoeba. And the second point was to characterize the isolates, so to make identification at molecular level, in order to give much more information about, generally speaking, about the molecular epidemiology, in order to better understand also the way of contamination and transmission, in order, as is written in the last line, in order to develop, in some cases, some countermeasures. We studied a couple of groups of amoeba, of water sample. The first one is in the area around Roma, in the region of Lazio, and we studied 19 water samples, and you can see that the origin was part from the domestic tap water and part from thermal water, coming from a program of research that we performed in the past. And the second group was from south of Italy. And also in this list, you can recognize different sources of water samples. And we have, for example, some ornamental fountain in the center of the city of Bari, like tap water, well water, and we tried also some sample of bottled mineral water in order to have some information about the occurrence of this amoeba. When we speak about the identification, we continue following a couple of steps. The first one is a morphological step. We use the petri dish with agar, with bacteria, and we perform the morphological diagnosis. But there is a critical point in this, there are several critical points. The first one, on the clinical point of view, is that for to perform a good diagnosis, we need to spend some days. And this is opposite to the desires of the clinicians that usually offer us, for example, a sample and the need of a quick answer in order to develop immediately and to establish immediately a therapy. So for this reason, we develop a non-made diagnosis, molecular diagnosis, in order to solve the clinical problems. We use primers specific for Acanthamoeba, and in a second time also primers less specific. Some results. These are the results concerning the two sampling sites, Lazio and Puglia. Red are Acanthamoeba, founded in 18 samples, 24 for living amoeba, and 12 were negative. Some information about the identification. On the basis of the molecular analysis and the description of genotypes, we describe, in this phonetic tree is quite clear, the separation between the two genotypes, a couple of genotypes. T4, that, as I mentioned in the beginning, continue to be the most common genotype present in our country also, and the genotype T15. T15 that is possible to recognize here in the second is typical only from south of Italy. And in a certain sense, this data confirm and is overlap in a good way with our clinic data about the occurrence of keratitis in the south of Italy due to the genotype T15. Concerning the other free-living amoeba, we have actually at the moment the opportunity to identify a lot of Artmanella or Vermamoeba. The taxonomy is quite uncertain, still uncertain, but as you can see, is quite common between the other, the group of free-living not Acanthamoeba to find this genus. This slide is probably the most important of the talk because here I can start overlapping the data concerning, already obtained concerning the clinical samples in yellow with the environmental sample in green. And I start having a certain coherence between the two data. For example, in Lazio region we have a prevalence of T4, and T4 is the genotype circulating in the local waters. While in south of Italy, in Puglia, I start having also at the environmental level the T15 genotype that I already recognize in the patients. So, concerning Artmanella, there are no clinical data, clinical evidence, diagnosis on keratitis due to Artmanella, but in few time we expect to find some clinical cases due to the massive circulation also of this genus, this species. And to make a general conclusion before the eventual discussion, with this study, we, with the molecular diagnosis of the genotypes, add new data to the environmental free-living amoeba circulating in our country, and there is we can confirm the different water source in Italy that may act as reservoir of amoebic strain potentially pathogenic for humans. And this is also the reason, because in my opinion it's necessary to develop a monitoring system also to the water, the free waters, to avoid or to limit the contact with the humans. Thank you.
We have time for a couple of questions. Enzo?
Do we have enough scientific knowledge in order to identify the possible preventive measures? First question. The second question, you said that we know that Acanthamoeba and Adamoeba can carry some pathogenic organisms, but it's possible that they can transmit the disease at the dose that you can assume. I mean, there is a problem of effective dose of these microorganisms.
The answer to the first question, yes, in the sense that we have, we are trying to demonstrate that the free living that we can identified at the genetic level, so distinguishing the different genotypes, are pathogenic or not. Because we start having evidence in overlapping between the environmental data and the clinical data.
Compared to the microorganism, bacteria, for instance, and virus.
That is the second.
Okay, sorry.
Probably is the second question or not?
I'm sorry, I was confused.
And concerning the second, the problem is demonstrated with Legionella, for example, but it's still in work to demonstrate for the other possible bacteria carried by the amoeba. For Legionella, it's quite clear because, for example, we have some important doses, important intensity of infection sometime in the waters. And inside we find a lot of Legionella. And it's possible easily to recognize with the molecular methods, for example.
There are epidemiological evidence, studies that can demonstrate that through Acanthamoeba you can transmit also Legionellosis, for instance.
It's quite clear by the scientific literature that it is a major carrier of the Legionella. And usually you find associated in the infection. And our proposal, but is a proposal by parasitologists, is to use the potential use of protozoan as indicator, as tags of the quality of water due to this capacity to carry the bacteria, for example.
Thank you.